We're going to learn about how to find the area of a regular polygon. This is video 1.01. Here are some examples of regular polygons. An equilateral triangle, a square, regular pentagon, and so forth. These are called regular polygons because all of the sides of the shape are exactly the same, which has some interesting properties. Each of these shapes can be split up into isosceles triangles. The number of isosceles triangles will match the number of sides of the shape, and we can use our formula for the area of a triangle, but we're going to make some adjustments to help us understand the shape a little bit better. So instead of B and H in our formulas today, you're going to see different letters, but they'll mean the same idea, the base times the height. Here on my regular pentagon, I have a few things labeled. We want to be very specific about what we're talking about because the distance from the center to the edge, which is the vertex, could be different depending on if I choose the center to the vertex versus the center to the edge. So they created two different terms for these. If I'm talking about the center to the vertex, we call that the radius. Similar, like if I put a circle around this, that would be the radius. If I'm trying to talk about the center to the edge, that is going to be called the apothem. The apothem is very helpful to us in this instance because you can tell from our diagram, this is also the height of the triangle. So if I'm trying to find the area of the shape, the height of the triangle is going to be a very important piece. Now later, we're going to see how we could use the central angle. And the central angle, something to know, is that it's taking 360 degrees and dividing it up by the number of triangles or the number of angles. So in this case, there are 5 congruent angles that make up that circle. So I could do 360 divided by 5, and I would get the central angle of the shape. Now, the area of the regular engon is basically just adding up the triangles that make up the shape. So in this case, our height and our base are going to be represented by different letters. So our height is going to be A, the apothem, and our base is the side length. But because we're not just trying to find the shape, the triangle area, we're trying to find the area of the whole thing, we're going to multiply that by the number of sides, which should be the same as the number of triangles that make up the shape. Now, if you think about it, the number of sides times the side length is basically the perimeter. If I walked around the outside of the shape, that would be the perimeter. So I can simplify this by just using P, or capital P, as that part of the formula. Let's see how this works. Now I've tried to format this to look similar to how Mr. Nelson showed you to do formulas in science. So if you like this format, it helps me to understand what you were looking for and how you showed your work. Here in the upper left corner is what we're looking for. We're asked to find the area. I know the apothem, lowercase a, is equal to 3 centimeters. That's what's labeled on the shape. The side length is 4. And I can count the number of sides of the shape, and there are 8 sides of this regular octagon. All I do is plug in my numbers, multiply, and I get 48 centimeters squared. Another way you could write this is square centimeters. Now this is a harder example. They've given us significantly less information and significantly less useful information. So I know that this is a pentagon, and I'm told that it's a regular pentagon. I'm given that the radius is 4, and I'm given absolutely nothing else. But because we know some information about isosceles triangles, and because we've learned a little bit of trigonometry, we can actually find the area of this polygon using that one number. Fascinating, I know. So I've split this up. In the top half, I have just the calculation for the area. But because I had so much missing information, I don't know the apothem, I don't know the side length, and I definitely don't know the perimeter, I split it into 2 parts. So in order to find those, I'm using these calculations down below. So the first thing I did is I figured out what is the central angle of this pentagon. And as you remember from before, 360 degrees divided by 5 triangles or 5 angles gives me the central angle. So down here, I've labeled my triangle to make it a little easier to follow, ABC, with D as the point where the apothem meets the edge of the pentagon. So here's my central angle. And because this is an isosceles triangle, this altitude splits the angle in half. So it makes 2 congruent halves. So the next thing I do is I split the central angle degrees in half, and I get 36 degrees. Now from here, I can use cosine and sine to find values that are equal to the apothem, which is AD, and the side length. But because I'm working with this right triangle here, I'm not actually going to find the entire side length C to B. What I'm actually going to find is just D to B. So at some point, I need to multiply DB times 2 to figure out the full side length for CB. Once I know the side length and I know the apothem, it might be helpful to just multiply our side length by 5 to get our perimeter. So 8 times 5 gives me 40. 40 sine of 36 degrees gives me the perimeter. Now, once I had all of this information, I went back up top and plugged it into our area formula. Now, when you do this, please, please, please make sure that your calculator is in degrees, which is represented usually as DEG, not radians. Radians is not going to be very helpful to you, and I really want to make sure you get full credit on these problems. So degrees, not radians. Check it. Even if you're using your phone calculator, it will switch it from radians to degrees. And think of how you could use those creative trigonometric properties. See you in class.